Hello, Professor. Hope you are doing well. My name is Maratita. Today, I will be presenting on hierarchical clustering. So, hierarchical clustering is basically done into the two spaces. First one is the Euclidean space, and the second one is the non-Euclidean space. When it comes to an Euclidean space, this algorithm can only be used for relatively small data set. The algorithm works basically into the two-step. First one, it begins with every point into its own cluster. Into the second phase, the larger clusters are formed by combining two clusters. While combining, we need to have answers to the following questions. How will clusters be represented? How will we choose which two clusters to merge? And the third one is, when will we start combining these clusters? Once we get the answer to this question, we can implement this algorithm depending upon our data set. Then the next one is the efficiency of this clustering method. This algorithm is not very efficient. It takes total of order of n cube type. There are different ways to which we can increase the efficiency. First one is that we can define rules about how many clusters are going to be there into our data. Second one is that we can stop combining at a point when we get a cluster which is inadequate in nature. Third, third way is that we can continue to combine until we get only one cluster. But instead of returning one cluster, we will be returning 3D presentation so that it becomes easy to have a connection where like which two clusters were combined at what point. Next point is that when it comes to a cluster merging, we have some set of rules that we need to keep in mind. First one is that we need to find out a pair with the smaller distance between their centroids. Second rule we can take into an account is that taking a distance between two clusters, which is the minimum distance between any 2 points, one chosen from each cluster. In the third rule, we can take the average distance of two pairs of points from one from each cluster. Fourth approach will be selecting the diameter when the diameter is the maximum distance between any 2 points. So when we need to select a cluster to be merged, we can go with the cluster which has the smallest diameter. And the fifth approach will be considering the radius of the cluster. So we can select which has the lowest radius for combining. Next is that hierarchical clustering in the non-Euclidean space. In this non-Euclidean space, we cannot combine points into this cluster. So we need to have some distance measures such as edit distance or the cosine. In this situation, our only choice is to pick one of the points of cluster itself, which is called as the clusteroid. Clusteroid is nothing but a point which is close to all points of the cluster. So in a sense, it lies into the center. When selecting a cluster, there are different points we need to keep in mind, such as common point will be that selecting as the clusteroid is the point that will minimize the sum of the distance to the other points into the cluster. Second one, it will maximum distance to other point in the cluster. And the third one is sum of the squares of the distance to the other points in the cluster. This clustering algorithm has its own advantages and disadvantages. The very good advantage is that it is a powerful technique which is really very easy to implement, and it allows you to build a tree structure. A second advantage is that in this method you can see the subclusters which are related to each other and how far apart these are. The disadvantage is that it is not suitable for the large data set. And another disadvantage is that you cannot undo the previous step. Once the instances have been assigned to a cluster, they can no longer be moved around. With this, I would like to conclude my presentation. And at the end, I would like to have one question asked to the students is that how much time does hierarchical clustering algorithm takes in Euclidean space? Answer to this question is order of n cube. Thank you.